Hey folks, so for today's Grasshopper tutorial we're going to be going over surface continuity methods. So modeling things like Zaha Hadid's 3D knitted formwork pavilion, or a lot of their other kind of soft formwork models, and also things similar to Felix Candela and the type of thin shell vaults, those types of structures. That's what we're going to be getting into today. This requires Weaverbird as a plugin for Grasshopper, which can be found here. So please make sure this is installed. You can download it for Rhino 6 or whatever version you're running. But this is how we're going to produce these sort of smoothened, continuous surface models. So let's hop into it. Okay, so I've got an empty Rhino model, and I've got a Grasshopper definition up here. This is fairly straightforward, pretty simple definition, but what we're going to be getting into today is how you can use Weaverbird to take a faceted planar model and smoothen it into something that is sort of soft or continuous in its surface definition. So I've looked at how to model Zaha Hadid's 3D knitted formwork pavilion. So I've taken a shot at that, so I can show you how Weaverbird takes a faceted model and converts it into this sort of smoothened mesh or smoothened continuous surface. So I'm going to just turn on this layer, and what I've got shown in Rhino right now is sort of the end result, but this is the faceted Rhino model. So it's created with a series of four-sided planes, very simple model, and then the Grasshopper definition converts it to what you see on the right here, which is this sort of smoothened, continuous surface where all of the hard edges get rounded over or filleted or softened, which produces this kind of continuous surface model. So all of that occurs within this definition, so that's what we're going to jump into today. So let's give that a shot and let's kind of rebuild it step by step. So we're going to start in Rhino first. Most of your time is going to be spent in Rhino setting up your faceted model. So let's create this first, and then we'll hop into Grasshopper and we'll rebuild the Grasshopper script kind of piece by piece after creating this. So let's minimize that. So what I'm going to do is pretty much just construct this guy and this guy, and then we basically just copy it 3 times to produce the whole shape. So this, not a very difficult piece of geometry to produce. I'm just going to draw a line and extrude that curve upwards. Do it a second time and a third time. And then if I hold Control and Shift at the same time, I can select an edge, turn on my gimbal, and just scale that edge outwards, and it's going to create that flare. And then I can come in here, select these edges, I can pull those in. Now you see that didn't stay attached, which you don't want. So I'm actually going to join these 3 surfaces and then hold Control and Shift. can scale those inwards. And those edges are going to stay attached. That's really important. You don't want any kind of like loose corners or edges. Everything needs to be sort of continuous. And then this thing kind of flares out a little bit. So again, hold Control Shift, grab that edge. I'm just going to push it outwards. Okay. So that's the first part. And then the second part is this kind of vaulted condition with this sort of elongated top piece. So for something like this, I'm going to create sort of a box that has two sides, and then a top that has three faces, and then I'll extrude those three faces upwards. So let's grab a line, copy that line over, and extrude those curves upwards. I'm going to repeat that extrude curve command, extrude them upwards again, and that's going to give me my two walls. And then I'm going to extrude this edge, but I want to bring it over. So actually what I'm going to do is I'm going to draw a line from there to there. Then I'm going to extrude, or I'll divide this line into 3 segments. So that gives me points to extrude to. And I'll extrude this edge. By default, it's going up. I want to change the direction, so I'm going to click direction. Click on first point, click along that curve. It's going to allow me to extrude it along that curve, so I'll extrude to that point. I'll do the next edge, change the direction, and then I'll do it a third time. And again, change the direction. Okay, so now I've got that set up, and then I need to extrude these 3 edges upwards. So I'll take that edge, and that edge, and extrude them upwards. Okay. Then what I can do is I can take all of this. I'm going to delete the curves and points. Select those ones. Don't need any of that. I can select all of these surfaces and hit F10 on my keyboard and open up control points. I'm not really sure what it's giving me there, so let's just try it on a little bit. There we go, that's better. So before you turn on your control points, select all your surfaces and type explode. And that's going to convert the extruded surfaces from an extrusion into a surface. Now when I turn on my control points, all the control points should be sitting at the corners of all the surfaces. And this will allow me to manipulate the shape so it looks something more like this. So I can take these, using my scale tool, I'm going to scale these inwards. And then I'm going to take these top points and push them upwards a little bit. And then to get this kind of flare, I'm going to pull these outwards and downwards. Okay. So now I've replicated that kind of vault condition, and I've got this guy over here as well. So now the trick is getting these oriented correctly, right? Because this thing's being rotated around a circle 3 times, right? 1, 2, 3, and then this piece infills between them. Okay. So what we're going to do is I'm going to first delete these because we don't want them anymore. We're going to create a circle. And we're going to create a line in that circle from the center point straight out. And we're going to create a line between the front of that vault. So I'm going to select all of this and use the midpoint of that line to align myself to here. Okay, and I might just pull this out a little bit so I have some more room. Then I want to copy this around 2 more times. So what I'm going to do is I'm going to select this curve and divide it by 3 segments. So that gives me 3 points. 1, 2, 3. So I can select this now. All of these pieces, including this line. Type rotate. I'm going to rotate it from the center out and align it with the first point. I'm going to repeat that command, but this time I'm going to click copy yes at the top. Reference. I'm going to copy it 3 times and make sure you hit that point. Okay. Now we need to get this piece to fill in the gap. Now you could take this and try and get it to move so that it fits, but what I'm going to do is I'm just going to loft the edges and create this piece of geometry sitting inside. So I'm just going to type loft, select my first curve and my second curve, hit enter, and it's going to create that surface between the two. We'll do it again, and a 3rd time. So it kind of filled in that gap. And then I can go again, and all I'm doing is hitting right click to repeat the command. So it's just a loft command every single time. And then you see how this flipped? We don't want that to happen, so we have to go to Align Curves and click this little button. I'm just going to click on one of these 4 points. That's going to fix that. Click OK. Loft, and that's going to flip it again, and I'll explain why in a minute. Align Curves, click a point, then it'll resolve the flip or the twist, and then loft, again, Align Curves, flip. Okay. So now I've created that shape. Now that object, or these surfaces on those last 3 lofts, those were flipping or twisting like that because this surface is not facing the same direction as this one. So you see how this is red on one side and gray on the other? That's your negative face and your positive face. So if you're seeing gray on both sides, let's open up our options. Let's go into View, Shaded, and scroll down until you see Shading Settings. Under back face settings, you want to set this to single color for all back faces and set it to red. What you want to do is make sure that all of the red is facing one direction and all of the gray is facing the other direction. So I'm going to select these faces that are inside out, type flip, hit enter. That's going to flip the direction of those faces. So I'm just going to go through and grab all the red ones and make sure these all get flipped so that I have gray on the outside and red on the inside. Okay. I'm just going to get rid of this, and let's push this over. Now I don't need any of these curves anymore or points, so I'm just going to do cell CRV, hide, cell PT, hide. Okay. So this is my faceted object. Okay. What we're going to do is we're going to take this object, all of these surfaces, we're going to reference them in the Grasshopper, and use Grasshopper to smoothen this object over so we get a nice smooth continuous surface out of it. So let's open up Grasshopper and let's rebuild this thing piece by piece. So we're going to start with a surface node. Just type srf. I want to reference all of these surfaces into this one node. So I'm going to right click, set multiple surfaces, drag select over all of them, enter, and now they're all referenced. Next thing I'm going to grab is a mesh UV. So we have to convert all of these Rhino NURBS surfaces to meshes. And we're going to give them a density value. Weaverbird only works with meshes, it doesn't smoothen over NURBS geometry. So what we're going to do is click, type mesh UV, and we want, let's see it popping up here. Let's see, we're going to mesh. Mesh surface. Search that. There we go. This is what we want. Mesh surface. Create a surface UV mesh. And so what we're going to do is plug our surface into mesh UV. So it's asking for our surface geometry. I'm going to hide all this Rhino geometry, and then I'm going to turn off the surface one. Okay. And then what we need to do is define the density of the mesh. Okay, so by default, each face of this faceted object is broken up into a 5 by 5 mesh. So if we look at that, we can open up our mesh edges node. And this allows us to just preview what that looks like. So every single face, or every surface that we created, now is broken up into 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 UV coordinates for that mesh face. Okay, that's important to understand because the density of this mesh determines how smooth the resulting surface is going to be. So I'm going to set this down to 1 and 1. So I'm just going to type in 10 in my number slider, hit enter, and that's going to pull up 10. So right now if I plug this into U and V, I'm going to get a really dense mesh. It's not what I want. I'm going to turn this all the way down to 1, and it's going to look exactly like our faceted surface model did, which is what we want. Okay. The next thing we're going to do is join all of those meshes together. Right now I've got 39 meshes. I want it to be read as one single mesh. So I'm going to type mesh join. Click that. And it should join all of those meshes into one single mesh. So I've got 39 values coming in, 1 value going out. Okay, so I can turn off this. And then the next thing we're going to have is called an align vertices. And basically what this does is just make sure that all of your vertices are connected. Vertices are the points at each corner of your mesh. So it just makes sure that right? So I've got a point for this surface and I've got a point for this surface. And all this does is it ensures that those 2 points are actually right on top of each other. Sometimes they can be like off by like a millimeter or something, or some tiny distance. You can't really see it, but it can screw things up a little bit. So this just ensures that everything's close together. The next thing we're going to grab is a Unify Mesh. Again, you're not going to see any change here. Make sure I grab the right one. Plug that into here. This Unify Mesh, what that does is, if you remember when we went back and we started flipping all of our faces to make sure everything was oriented in the right direction, so red was on the inside and gray was on the outside. This command in Grasshopper does the same thing, it just automates that process. So it'll automatically go through and figure out how to flip each face so that it's facing the correct direction. So I always throw that in just to make sure all of my faces are oriented properly. And then we have this weld command. Now the weld command ensures that anytime 2 vertices are sitting right on top of each other, they're joined into one single vertice. Right, so I've got 2 faces here. I've got a face here and a face here, which means I have a vertice on the corner of this surface and I have a vertice on the corner of this surface. I want it to be read as though there is only one vertice that is shared by both faces. That's what your weld command does. It'll analyze the entire mesh and it will weld every single vertice into a single vertice that is shared by all faces that are touching that corner. It's also very important to do. Alright, now we're going to get into our Weaverbird stuff. This Weaverbird Catmull-Clark command. Okay, Catmull-Clark is a guy who actually developed the mathematics that are required to take a faceted mesh and smoothen it. So you can Google that if you want to and really get into it. But this is the command that we're going to use from Weaverbird that allows us to smoothen over our mesh. That's going to live under our Weaverbird tab. And it's this red icon here, Weaverbird's Catmull-Clark subdivision. We're going to pull that in. And we're going to tie in our welded mesh into the mesh input of our Grasshopper script. And right away you'll start to see this mesh is now smoothing over. Okay, so if I turn off all of these components beforehand, I'll leave the wireframe on so you can see what the wireframe faceted one looks like. And we're starting to get this rounded, smoothened mesh out of it. Okay, so there's a couple options to this Weaverbird Catmull-Clark node. Your first input obviously is your mesh. The second input is the number of subdividing iterations. This is the level of smoothness for a mesh. Okay, what that means is the higher that number goes, the smoother the mesh looks, the smoother the curvature looks, the denser the mesh is. So I'm going to double click, type 3, hit enter. Now I'm going to set this to 3, which is really the max you will ever need to go. And you'll notice that if I switch between these, let me just turn off these edges. If I switch between 0, which is faceted, doesn't look any different from our base mesh. 1 is kind of smooth, but still fairly faceted. 2 is smoother, but if you zoom in, you can still see straight edges. And then 3 is super smooth. So you really don't see any straight edges anymore. Okay, that's kind of the level you want to be at when you've finished with your model. This third input is how you define naked edges. Your naked edges are the outside edges of your model. So that's a naked edge, that's a naked edge. Interior edges are ones that are shared by two faces. Okay, so that's an interior edge. You can set your naked edges to either smoothen over. Right now they're smoothening, see it's rounding over. But if I set this to fixed, it's gonna force them to all be faceted so they don't get smoothened over. And I can set it to corner fixed, which is what we want, which means that moment will get rounded over, but that moment, because it's a corner, will stay faceted. So I'm going to set this to corner fixed. Okay. So it's rounded, but not at a corner. And so we're just going to set it there. The next thing we're going to do is give this thing some thickness. So if you want to smoothen your mesh more than 3 subdivisions, this number can't go above 3. Okay, 3 is the densest you can make it. If for some reason you wanted to make it smoother than how it looks now, you can copy and paste this and just send it through another smoothing iteration. So I'm going to do it twice and get like a really smooth mesh. And so you can start to see, if I grab our mesh edges mode again, and I pull that into here, I get a really, really dense mesh. Okay, super clean. So this will end up 3D printing really well. So then we want to give this some thickness, so it actually is 3D printable and acts as if it is a shell and not just an open surface, right? Because right now this has no thickness to it. So we're going to use this Weaverbird Thicken node. Let's see if we can, yep, this Weaverbird's Mesh Thicken. So it wants our mesh, so we'll plug that in there. It wants a distance, so I'm just going to type 10.000. That's going to be too thick, so I'm going to throw this down to like 2. Put that in there. Okay, and you can see that mesh is getting offset to the inside. Okay. And then offset type, distance on diagonals, hypotenuse average, planes and intersections. These are just different ways of offsetting the mesh. I usually keep it at its default. It's usually fine. And then just set the distance. And I want this to be fairly thin. So I'll set it like there. Turn off that preview, turn off our mesh edges. We're going to end on something like this. So then you can take this, bake it out, click OK, and you've just converted your faceted piece of geometry to this hyper smooth mesh. Okay, this has thickness, so you can 3D print this. You can do, kind of whatever you want with it at this point. You can render it, take drawings of it. And it's a nice clean piece of geometry, meaning there's no self-intersections. You want to always watch out for that, which is essentially just hide all of this. If I were to extrude this so much, you'll notice here you get this crimping effect. Okay, if I were to bake this out, I've thickened this so much that the surfaces are starting to self-intersect. That's really poor modeling. You never want to let that happen, especially if you're trying to 3D print something. So you just want to keep an eye out for that. Okay, don't ever let your meshes intersect like this. Okay, you always want to make sure things stay nice and clean. No intersections. Usually thin surfaces do that better than super thick ones. Okay, so you can use this definition to smoothen over any kind of like faceted object that you can think of. And if you want to do something that's 3D printable from an extrusion printer, then you always just have to kind of work your way upwards. So let's try and create something else real quick. I'm just going to create a box, explode this, delete that, delete that, delete that. So I've got kind of two planes I'm working with, left and right. I'm going to pull them in close to each other using the scale tool. And then I'll copy these upwards twice. Then let's see, I'm going to join all these together. Hold down Control and Shift at the same time to grab the edges, scale them outwards. Then I can do something like that. Okay, and so if I select, I'm going to explode these now that I've got them where I want them. Select all the surfaces, input it into our surface node, so set the surfaces. And you can start to see how this is going to begin to smoothen over these new surfaces. So I'm going to turn down, keep our thickness pretty low. I can even select all this stuff, hide it, and you can start to get these really smooth looking surfaces. And then you can start to mess around with, okay, what happens if I loft from here to here? And then select all those surfaces, update the surface node, so set multiple surfaces. And now I'm getting that kind of like rounded over moment. And those two surfaces have now joined together. Okay, so a lot of Zaha's like hyper smooth towers that have really complex curvature to them, this is how they're made. By starting with a faceted object and using Weaverbird or some kind of mesh topology tool to smoothen everything over. And of course this will update real time. So if I grab two bottom edges, I can pull them apart and that will all update. I can grab, yeah, so anything that you can kind of come up with will be able to be input into this. So I could loft this and this, grab all those, update my surface node, and it will close those off as well. And then what I can do is I can right click, bake, and bake that surface out. So you can start to produce some really nice continuous surface models this way as well. Then if you want to check it for 3D printability, depending on the 3D printer you're using, you can do what's called a clipping plane. in Rhino. So I'm going to select the object, type the pin plane. It's going to ask for a rectangle to be drawn. And I can move that rectangle up and down to see how this thing's going to print, right? And basically what you're looking for are no undercuts. So as long as this surface continuously builds upwards, I can 3D print this without any support material. So I can 3D print this on a typical extrusion printer. Okay. So that's a good way to check if you can 3D print something. Yeah, that's pretty much the whole definition. Again, it's all about how you determine your faceted model, is how you change or alter the shape or the smoothened shape that results from it. So it's just kind of back and forth. Set the definition and then start messing around with the faceted object in Rhino. The trick is to stay with as few faces as possible. It's easier to manage, easier to use, so less is more in this case. So always start with just a few faces and then you can build on top of that. You can always copy and paste things once you figure them out. So I can take this whole series, copy it, move it up. So I've got this thing kind of attached there now. Right, I can select all of this, set multiple surfaces. Now I'm really starting to get some weird stuff. Take that out. Right. You can see how you can start to get complex very quickly using very simple geometry. Okay, that's sort of the whole game here. Keep it simple in Rhino and then let Grasshopper produce the complexity and these hyper smooth types of surfaces. And that's about it for this one. Thanks.